Okay, now fundamental theorem of calculus. Fundamental theorem of calculus, FTC. Okay, we have two parts. The first part is part 1. Is suppose we have a function g, but this function g is defined using one integral, right? 0 to x, f evaluating any arbitrary variable t I want to call integer. If you differentiate this g prime, the answer is we come back again to the f case. T is completely dummy variable. When you compute the antiderivative of this and evaluate between 0 and x, we have x here inside the function, no? The g. And I suppose that g and 0 is 0. Okay? The fundamental idea is that the derivative and the integral undo each other, cancel out. Okay? Let's see more clear and a little bit more complicated. Suppose now that we have again the integral from 0 to x of the one function f. I'm using another variable, u du, because it's completely dummy, completely arbitrary. But here no. Here I complicated thing. No x. I put it g of x or h of x, another function. And you differentiate this, dx. Okay, this is another way to create this notation. Okay, you differentiate d dx. This is the same of the prime, no? Okay, now this derivative and this integral undoes, and we have now f evaluating the upper limit, que es h of x, time, using the chain rule, because you are doing the derivative of the compound function, derivative h prime and x. And we suppose that f and 0, this is minus, no? F and 0 is 0. And the answer is f h prime times h prime x, h of x times h prime of x. Okay, this is the first part of the fundamental theorem of calculus. Okay, the fundamental theorem of calculus part 2 is, it's a classical formula. Suppose the integral, define integral of the function f of x dx. You compute the antiderivative, que es capital F, and you evaluate in between b and a. Okay, this is the way to evaluate the defined integral. Okay. Example to understand much better. Using the part 1 of the fundamental theorem of calculus to find the derivative of the function. Okay, my goal is find g prime of x, and the derivative of the integral is cancelled. It's a natural logarithm of x, que the upper limit, minus natural logarithm, and derivative x with respect to x is 1, therefore it's invisible. Okay, and logarithm of 1 is 0, therefore the answer is g prime of x is equal natural logarithm of x. Okay, again, using the part 1 of the fundamental theorem of calculus to find the derivative of the function h. My goal is find h prime. In this case, you know that the derivative antiderivative is cancelled, so we have tangent inverse of 1 over x times derivative this is negative 1 over x squared, no? Minus tangent inverse of 2 times derivative 2 is 0 And this part is always 0 when you have a number here. When you have function, no. But when you have number function, yes. And what's the final answer? The final answer is h prime of x is equal minus tangent inverse of 1 over x divided by x squared. Again. Okay, example 3, exactly the same. We using the part 1 of the fundamental theorem of calculus to find the derivative of the function, in this case the name is p. We need to find p prime. But the only confusing part is the limit the upper is constant, the limit the lower is a function. But it's okay. We can change. So we can change using the property for defining integral. We can change 0 e to the x. I know that this is negative. But this is the same function. This is the same function p. And the derivative is minus derivative and antiderivative cancels out. Entonces es la que sine, okay, sine cubic of the e to the x times the derivative e to the x, by the way is the same, minus 0, no? Minus 0 because this is the constant and the answer is 0. The answer is minus e to the x sine cubic of e to the x. In general, when you have a function is defined by one integral and the both limits, lower and upper, are a function, so it's a little bit more complicated. The derivative and the antiderivative cancel, to stay f, evaluate np, p of x, times the derivative of p, minus, again the function, but evaluating h, que es the lower function, times the derivative of h. This is general form. When the one limit is constant, does it disappear? Okay, it's the same problem. You need to find g prime. Okay, remember the derivative and the antiderivative cancel, so you have the function, but evaluating the upper, que es 3x squared plus 1 over 3x squared plus 1. This is minus, here is minus. Look, n minus, n minus. Multiplication by the derivative is just 3. Minus. Now exactly the same is 2x squared minus 1 divided by 2x squared plus 1. Multiplication by the derivative is just 2. Okay, so the final answer is 3 times parentheses 9x squared plus minus 1 divided by 9x squared plus 1 minus 2 times 4x squared minus 1 divided by 4x squared plus 1. That's it. Super easy fundamental theorem of calculus.